Okay, 7.1 in your textbooks, we're looking at exploring equivalent trigonometric functions. So we'll start with chapter 7 here. We're using the principles that we've learned in chapter 6, and we're just applying them now to trigonometric functions and coming up and kind of creating the basis for the identities that you guys are familiar with from grade 11. So our goal is to identify equivalent trigonometric ratios. First thing says, what is a possible equation for the function shown? Craig, Aaron, Robin, and Sarah are comparing their answers to the question shown above. So Craig has a function, negative sine theta. Aaron's function, sine theta plus pi. Robin's function, sine theta minus pi. And Sarah's function, cos theta plus pi over 2. Their teacher explains that they're all correct because they have written equivalent trigonometric functions. So we should know this just by looking at the graph, right? We should know and be able to do these translations in our head already, right? So we're all familiar with the graph y equals sine theta or sine x. Okay, we're familiar with that. So going from this to these other functions, we just use the translations that we know. So the first thing is we translate across the x-axis. So this function then, if it's negative sine theta, would just translate across the x-axis. So we know that that function works. It's the same as this graph. Next one, we look at sine theta plus pi. So this is a horizontal translation where we're taking this initial parent function and moving it pi or 180 degrees to the left. So we'll also notice that, so this point then that was at 0 is going to move over to the y-axis. So then we end up with that same graph here. So we're taking this point here and we're moving it pi to the left to here. So the function ends up being the same. Sine theta minus pi, same idea, but this time we're moving the graph to the right. So this graph is actually moving from here over to the right. Sorry, the parent function is moving from here to the right. So this point goes from there over to here. Okay, so in each case we can see using the horizontal translations as well as the reflections that these are the same. We're going to graph them now and see if we can also see that on our graphing calculator. Okay, so as you can see here, it's tough to see actually the colors, but these graphs overlap each other. This is in green here. If I take off the green, there's no way to actually overlay them because they're identical. So here we can see the blue graph looks like that. The green graph there's no way to just turn it off, eh? Sine x minus pi. Okay. In any event, because all the graphs actually do overlay each other, as we discussed before, you can't actually see a difference on the graph, right? They all just lay on top of each other. Okay, so it's kind of difficult to see. But basically, based on those translations, we're going to have equivalent graphs. Okay, so we entered the student's equation in the editor, and they're using the radio mode. What do you notice? So we notice here that all the graphs are identical. Examine the table of values for each function. Let me just make sure. Yeah, that's right. Examine the table of values for each function. Are you convinced the 4 functions are equivalent? Explain. So if we were to create a table of values now here with y values here and our theta values here, then we would actually discover that all of the values are identical. Okay, and you can do that using your calculator. We don't have a table function on here. Creating equivalent expressions using the period of a function. So the next one is the graph sine theta. Using transformations, explain why sine theta plus 2 pi is equal to sine theta. Write a similar statement for cos theta and another similar statement for tan theta. So here we know we're familiar with the graph. Again, sine theta. If we take this graph now and we perform a horizontal translation of 2 pi, so we're moving this graph its entire period, so this is 2 pi. So the full graph is moving to the left 2 pi. So this point here is going to end up over here. So what we actually end up with is the identical same graph. Okay? So any trigonometric function that we translate in either direction, either the positive direction or the negative direction, we're going to end up with the same graph as long as we translate it by the same period. Okay? Any questions about that so far? So we're going to write a similar statement for cos theta and another statement for tan theta. So for cos theta, we know the graph looks like this. Who can... Sorry?
The graph goes up.
Yeah, thanks. So who can tell me what equivalent statement we can write for this particular graph? What horizontal translation will give us the same? Yeah.
Theta plus 2n.
Plus 2 pi, right? Yeah. So this would work, or this would work as well, right? Carlos, are you with them? Yeah. You're showing them around?
Yeah, but I should stay here with them.
You have to stay with them? Okay. So in either direction, if we translate it to the left or if we translate it to the right, we're going to end up with the same graph. Okay? If we wanted to write one now for our tan function that we just learned, so this is y equals tan theta. What could we write now with a horizontal translation that would give us the same tan function? Yeah. Anyone else? Ramon? Yeah, Elijah?
Can you just do tan theta plus 2 pi?
Okay. Y equals tan theta plus 2 pi. So this is what you would think, right? This is what we did with cos, and this is what we did with sine. Who sees a problem with that? Alex?
Tan theta, it has a period of just pi.
Right, it has a period of pi. So if we move it 2 pi, we've actually translated it 2 over. We would, however, end up with the same graph. Okay, so this would work. Okay, we've just translated 2 complete periods over. Okay, so what I was looking for actually was tan theta plus pi. Okay, but if you were to use your calculators and you were to try tan theta plus 2 pi, tan theta plus pi, you'll get the same answer. Okay? Every time. Any questions about that? So when we take a trigonometric function and we translate it to the left or right by its period, it's going to be the same function. Okay? That's the conclusion of what we're getting at. All right, next. Okay, we're creating equivalent expressions by classifying a function as odd or even. So, what do we remember about odd functions? Review, what do we remember? It's a couple of chapters ago. What's an odd function? Okay, so it's symmetrical. Somebody said symmetrical what? No. Anybody remember? Yeah, Kevin?
Symmetrical about the y equals x axis.
No. It's symmetrical. It's symmetrical about something. Nao, do you remember?
Does that have to do with n being x or?
No, Maferi, do you remember? No?
Oh, sir, algebraically, isn't it f of x equals f of negative x?
Yes, good. It has symmetry about the origin, yeah. Okay, and even functions, they have symmetry about the y-axis, good. Sorry, even function is negative x. No, sorry, that was right.
Negative at f.
Negative f at x.
No, that's odd, yeah. So this was right. And then for odd functions,
You flip them.
that's flipped? No, that's right.
So the one at the
No,
bottom
it says
is
odd functions, and then you
Yeah.
have f at x is equal.
Yeah.
Oh, sorry. Yeah.
So, so we go back.
Yeah, my mistake. Sorry, guys.
Flip the function.
Okay. Remember, the way to remember is odd is always has the two negative signs and the even just has the 1 on the x value. Okay? So, if we have f at theta is equal to cos theta is an even function because the graph is symmetrical on the y-axis, use transformations to explain why cos negative theta is equal to cos theta and then verify by graphing. So, if we graph, here's our y equals cos theta. Now we want to graph y equals cos negative theta. So what's going to happen then, these values that were positive here are now going to become negative. So the x values are going to switch. Cos negative theta. So these values, these x values switch. So what we see is that there's a translation across the y-axis. You guys understand that? So these values that were positive now become negative, and it's actually the same graph. You guys see that? So if I were to take this graph and I were to fold it across the y-axis, I would get the same graph on the other side. Okay? So these values here and here would become here and here. Okay, any questions about that? Alright, for an odd function now, we want to prove that the graph of y equals negative sine theta. We know sine theta looks like this. Negative sine theta is going to go the other way and look like that because we've already flipped in the y. Okay, we want to prove that that graph is going to look like So what we find again now is if we flip this over across the y-axis, the x values become negative, it becomes the same graph. Okay, so this flips. This again being folded across the x-axis becomes negative. So the difference is one is the original function and one is the negative reflection across the x-axis. So this is our odd function, again, which we can see is symmetrical amongst the y-axis, and this is our even function. Even right across the y, odd is symmetrical around the origin. Okay? Any questions about that? Alright, G says classify the tangent functions as even or odd. Based on your classification, write the corresponding pair of equivalent expressions. So we need to do the tan function now. So we know the original tan function looks like this. Okay, there's our tan function. So what do you guys think? Even or odd? Okay, Alex says odd. How come?
It's symmetrical around the origin.
Right, it's symmetrical around the origin. Good. It's not symmetrical amongst the y-axis. If we take this and we fold it over, we're going to see we'll get something like this. Right? If this folds over the y-axis, we'll get something like that. So here we can see that it's actually an odd function. If it's an odd function, then we know tan negative theta. Yeah, thanks. Tan negative theta is going to be equal to negative tan theta. Alright, so we can go ahead and check that by graphing first tan negative theta. So we take tan theta and we're going to flip it along the y-axis. Okay, so there's tan negative theta. If we were to now graph negative tan theta, okay, we get the same answer. So you're taking our original tan function and we're flipping it across the y. So this becomes this. Do you see that? This switches over the y-axis, this switches over the y-axis, so we end up with this graph here. So these two graphs are the same. So again, odd function. Any questions there? Okay. Next. So the whole purpose of this, the whole thing is what we're trying to develop is we're trying to develop those identities. You know how we had those identities in grade 11 where we relate sine and cosine and tangent? We're trying to develop where they come from. Okay, so if you understand up to here and keep going, we're going to actually get to the point down here where we actually start to develop some of these identities that we've gotten used to. Okay, so H. Creating equivalent expressions using complementary angles. So H says determine the exact values of the 6 trigonometric ratios for each acute angle in the triangle shown. Record the values in the table, and one below describe any relationships that you see. So the first one, sine theta pi over 3. Philip, what's the exact value of this? Your special triangle is right here to help you out. Yeah. If you were paying attention, you would have got it right away, right? Right?
Yeah.
What's cos theta over 3? Or pi over 3? Yeah. cos. Cos pi over 3. Pi over 3 is here. He doesn't need help. He's good, he's good. Next one, tan.
1 over 2.
No.
Or 2, 3, 2.
Cosecant. This is easy now, right?
2 over 2.
Good. This one? Keep going for me. Actually, I'll let someone else. Andrew?
1 over 2. Root 3 over 2. And 1 over root 3.
Okay, Maferi?
2. 2 over.
Okay, good. So we know that our reciprocal functions are just obviously the reciprocal of our primary trigonometric ratios, and we know these ratios defined to us way back in grade 10 as opposite over hypotenuse, adjacent over hypotenuse, and finally opposite over adjacent. Okay, it says repeat part H for a right triangle. Oh, sorry. Record the values. Describe any relationships that you see. So what is the relationship? I just went over it. The most obvious one. Yeah. Yeah, that they're reciprocal. Okay, so there's the most obvious relationship. Repeat part H for a right triangle in which one acute angle is pi over 8 and the other acute angle is 3 pi over 8. So if we draw a right triangle here, pi over 8. Sorry? So here's my right triangle. Here's my angle pi over 8. And the other acute angle is 3 pi over 8. So doing the exact same thing here, we could calculate the hypotenuse, of course, pi over 8. So we would have to calculate the lengths of these sides and then do the exact same calculations for the trigonometric ratios. What we find is that the same results apply. So we get something that looks like this. So this is just developed using our calculator. Of course, these aren't special angles, so we would have to use our calculators. And we find that our reciprocal trigonometric functions have the reciprocal values. So this would be 1 over 0.383. So the values of sine and cosecant are reciprocals are the values of the cosine and secant and the values of tangent and cotangent. So that's the whole point of this, is we're just proving those relationships between sine, cosine, secant, okay, using just a random angle there and a right triangle. Remember, again, these are only for right angle triangles. So they were developed using right angle triangles, but they would work for any angles. All right. J. Any right triangle where theta is a measure of one of the acute angles has a complementary angle of theta pi over 2 minus theta for the other angle. Explain how. So why is this the case? First of all, who can tell me this? If we have a right angle triangle and one of our angles is theta, this is a right angle because it tells us, right? The right angle triangle. One of the angles is theta. So how do we know what this angle is? Yeah, Ramon.
Wouldn't you add it with 90 degrees?
Yeah, you're right. What would you do though? You wouldn't add 90 degrees.
No, would you add up like the whole
Yeah.
angle and minus it by 180?
Yeah, so that's one way to do it. So we know that 3 angles in a triangle equals 180. Okay, but we know if this is 90 here, 90 degrees, we know that these two angles have to be 90, right? So the two angles here have to equal 90, right? So this angle here is actually, you guys understand that? Right? Because pi over 2 is 90, right? So we're subtracting theta from 90 to get that third angle. So this sentence makes sense then, right? Any right triangle with theta as the measure of one of the acute angles has a complementary angle of 90 minus that angle for the other angle. Explain how you know that the cofunction identity sine theta is equal to cos theta 90 minus theta is true. So here, there's two ways we can prove this, okay? One is we can use graphs, and the other is we can use a triangle. So let's do the first way first. Okay, let's use a triangle. So if we have a right angle triangle again, let's say that this side is B, this is A, and this is C. Okay, here's our angle theta. Okay? So we want to prove that sine theta is equal to cos theta over 2 pi over 2 minus theta. Okay? We want to prove this. This is the first identity here that we're proving. All right. So the first step is let's find out what sine theta is. Sine theta here, of course, we know is opposite over hypotenuse, so A over C. Okay, everyone's okay with that. Next, if this is theta pi over 2 minus theta, which we determined in the last step, or sorry, yeah, that's right, 90 minus theta, then our cos, this angle, pi over 2 minus theta, is going to be the adjacent side now over the hypotenuse. You guys understand that? So this would be AC. Okay, so these values are the same. You guys see that? So therefore, sine theta is equal to cos pi over 2 minus theta. Alright, so that's one way to prove it. We can also prove it using graphs, right? So we know this is y equals sine theta. So that's one proof. Here's the second proof. Next we want to graph y equals cos theta. Okay. And finally, we want to graph y equals cos. Okay, I'll move in a second. Thanks. Okay, so the first thing we're going to do here is we're going to translate this graph. So we're going to move it. And we want to move it 90 degrees. So this is going to get moved 90 degrees. It's positive here, so it's going to move to the left. So this looks like this. So that's a horizontal translation. And finally, the last step is that we need to reflect the x value. So these values that were positive become negative. Okay, so we're reflecting now in the y-axis. We're flipping this over. So this now looks like this. And what you'll notice then is this new graph here this new graph that's this graph, which is also the same as this graph. Okay, so we've proven, therefore, y equals sine theta is equal to cos. Any questions there? Okay, so two ways. We can prove it either using trigonometry here, or we can use it, prove it using our trigonometric functions through graphing. Yeah, you can use either one. We're just trying to prove these identities right now so you understand where they come from. Okay, write all the other cofunction identities between pi and 9 or pi over 2 minus theta. Based on the relationship in parts h and I, verify each identity by graphing the corresponding functions on the graphing calculator. So what we end up proving using the exact same steps, again, is a little easier using triangles, but we end up proving that these are our trigonometric functions here. So we prove these identities using trigonometry or graphs. Okay, so we should be able to prove either of those using trigonometry or graphs using the exact same logic. Okay, any questions there? All right, finally, creating equivalent expressions using the principal and related axes. Explain how you can tell from this diagram of a unit circle that sine pi minus theta is equal to sine theta. Who thinks they can explain the first one? Anybody? Nailed? Come on, you know how to do this.
I just need one example first.
Okay, so the first example, sine theta minus, sorry, pi minus theta, that's this angle, right? Because we know this angle here is pi, right? So this angle here, right here, this is pi minus theta. I wish they used x instead of theta because I keep mixing up my pi's and thetas, but in any event, pi minus theta is this angle here. So we want to prove that this angle here is the same as this trigonometric ratio here. So we know from the unit circle that sine theta is our y component, right? Because it's opposite over our hypotenuse, and our hypotenuse here is always 1 because this is a unit circle, right? So sine theta here would be our y value here, y over 1. So sine theta is equal to y. Right? You guys got that? So now if I did the same thing on this side, I would find out that sine pi minus theta again is going to be y over here over 1. Okay? And y is still positive. Okay? Because we're above the x-axis. You guys understand that? Alright, Kevin, next one. Cos theta minus pi minus theta is equal to negative cos theta. Can you explain it?
So for cos,
Do this one first.
negative cos theta,
Yeah.
that would make it,
So what's cos theta first?
cos theta would be, so x over 1, so x, right?
Yeah, it's adjacent over our hypotenuse, just taking it one step back further. It's going to be x over 1, which is equal to x. So negative cos theta then would be?
Negative x.
Negative x. Good. Okay, so there's negative x. We've proven that. Next, we want to do cos theta minus, sorry, pi minus theta. So this angle. So do that one now.
So now that's going to be pi minus theta, so it's still x, right?
Yeah, well, it's not x.
So it's negative x.
It's negative x. Yeah, so cos theta minus, sorry, pi minus theta is equal to negative x over 1. Negative x. Okay? You guys starting to see how this works?
Sure.
All right, nailed. We did 2 for you. You're gonna do this one now.
Okay, so the y over x.
So so tan theta, first of all, is equal to, tan theta is equal to what?
Y over x.
Good. Y over x. So negative tan theta is equal to,
Y over negative x.
well, just, yeah, negative y over x, right? Just put the negative sign in front, right? Right?
Yeah.
Okay, so now you're going to do tan pi minus theta. So tan of this angle.
Oh, you want me to continue?
Yeah. You proved one. You got one part. Now you got to prove this part. So it's opposite over adjacent, right? So what's the opposite value?
Y.
Yeah. And what's the adjacent?
Negative x.
Right. Okay, so these values are the same. Okay? Any questions there?
Wait, why'd you have to do like the negative tan theta?
Because that's the question. It asked that, right? Right here.
Oh.
It had the negative sign there. Okay? All right. M, it says write similar statements for the following diagrams. So, we can do the exact same process, we're just looking at different quadrants now. So you do the exact same thing, you set them up, and we end up with these statements here. Okay, so let's look at a couple of them. Sine pi plus theta